In this video, we're going to look at database stereotypes. Now, typically when you're designing a system like Counter Fraud Management, you are going to rely on something called UML. And I'm talking here about the design at a database level. And UML is a general-purpose developmental modeling language in the field of software engineering intended to provide a standard way to visualize the design of a system. And you're probably already familiar with something like this, where you are visualizing the it's a sort of blueprint that does diagrams that allows you to visualize the tables. But one thing that's not quite so obvious is that the M of UML stands for the model. And so when you draw a diagram of the system, you actually have a partial representation of the model. So the model's sort of abstract, and the diagramming is obviously the more concrete representation, and it's always an incomplete representation of the actual model. And if you look at the School of Athens by Raphael, you'll notice that this is something you're probably already very familiar with. Here you have on the left Plato, who's pointing up in the sky because of these kind of ethereal forms that couldn't actually be realized in real life. And then you had his disciple Aristotle on the ground, who's kind of the father of modern science, saying, no, you have to look at the real world. And that's sort of the diagram on the right, and that's compared to the Platonic version of this kind of form, which is the model. And if you go to this website here, you see a nice description of what a stereotype is. It allows you to increase the vocabulary of a UML. You can add and create model elements derived from existing ones. And I'll let you read the rest of this. But the purpose is actually fairly straightforward, right? So if you have some sort of table here, and a table A and a table B, and we're talking here about in a relational database management system, that you will want to, and very often actually do, have multiple columns. And say you have an ID here and an ID here. When you do a join statement, so a SQL statement, you can get both table A in the output and B when you do these types of joins. So you would basically do something like select star from, your table A, left join, for example, B on, and then now you tell it what you want the join condition to be. So you're saying essentially A.id equals B.id. So a normal select statement would just give you one of the two tables, and a join would give you, both the content from both of the tables, depending on what you are looking for. And that's just by way of example. You probably are already familiar with quite a bit of that anyway. But this actually raises an interesting problem. So let's say that you have, as you know, in Counter Fraud, the database system, we model people with a party table and with a party name table. So we do not have, for example, an industry-specific pediatrician, so if in the case of medical provider fraud, or neurosurgery, or orthodontics, we don't have those sorts of things. So a traditional way to approach this kind of problem is to, for example, add a new column in here, and maybe you have a designation of what kind of party this is. So you might say, the profession, and the profession column would say exactly those things. So maybe neurosurgeon or something along those lines. Or you might create a third table out here, call it C, and maybe you call it professions. And this is a kind of mapping table or a kind of bridge table where you would take, say, you make a column, that same column essentially, call it profession, and then you have another column next to it that indicates which party ID represents someone who has that profession. So these are two separate approaches that you can take to kind of solve this problem. But there is another way to do this, and the answer is to use something called stereotypes. Now, a stereotype would not require you to create this additional structure. In fact, instead of expanding out in terms of the schema, because remember, this is basically a schema change, and that's also a huge schema change, creating a new table. Instead of doing that, you can add rows across instead of adding columns or adding tables through the idea of a stereotype, because as we saw before, the idea of a stereotype is to augment what you already have. So concretely, how does that work? Well, what you do is you take your stereotype and you create a new table. So yes, this is adding to the schema, but in fact, this is what we ship the product with. So that, and you'll see why we do that in a second. So we're going to have, and this you'll see this, there is a party underscore type, which represents the stereotype. And here is what that table looks like right here. Here's the description. You can see there's a party type ID, a name, description, stereotype, and an order. And now things start to get pretty interesting. So for example, we know that we have a party type ID as one of the columns, and we also have a stereotype as a column. Well, it turns out that this party type ID will be can be joined to a column here called party type ID and joined over here to party type ID. And that allows us to join effectively all of the tables together by using this idea of stereotypes. And you can see this too, right? If we do describe table CF fact party type, well, here is our party type ID. And if you do a describe table CF fact party name, take a look, we have party name type ID. And then we have CF fact party, and then we have party type ID. So this is how you get the three tables to talk to each other. And just to be clear about how they did this, they take the name of the table, which is party, and they append to it underscore type ID. And they do the same thing under party name, where they append to it underscore type ID. And in the case of party type, well, they just add ID at the end. And this is actually the kind of the genesis, the beginning of how you start, again, to get these three tables to talk to each other. So once you bake into the database this idea of stereotypes and types, you don't need to extend out the schema anymore like we were doing before, where you add additional tables and we add additional columns to existing tables. Instead, you add rows. And this is a feature called softly configuring, or softly configurable. You'll hear the term used with ICFM. Now, there is a limitation here. Remember that a stereotype will let you create new model elements, but they are derived from existing ones. So what happens if there is no existing column anywhere in the current CFDB schema? Well, if you need to actually add something brand new, then a stereotype really isn't going to be the right way to do it. Stereotypes are kind of like a derived class if you're used to classes. So they kind of derive from a superclass. That's actually the idea behind a stereotype, which comes from the world of printing presses, from which you had a kind of generic thing that you print that you would multiply, there's like a stamp that you would put onto the page multiple times, but that you could modify slightly once they were actually printed out. And indeed, our content packs will do exactly that. They will come out and change the schema by adding additional tables where they're needed. And you can see an example of that here: create table, create table, create table, create table, create table.